Amritam Gamaya.
Good morning, all.
Good morning, sir.
Good morning, sir.
Good morning. In the previous class, we have discussed about mechanical injection system. Okay, mechanical injection system in the diesel engine, how the diesel fuel is injected into the system. Now, in the today class, we are going to see the classifications of injection systems. Like in that injection system, two types of pumps are there, which are used for pumping the diesel fuel into the combustion chamber. Okay, so we'll be discussing about those two injection pumps. Yes. Yeah. Fuel injection pumps. So you know that the objective of fuel injection pump is to deliver the quantity of fuel under high pressure. You need to send the quantity of diesel fuel into the injector at a high pressure. That is the objective of injection pump. Okay, so we'll see to serve this purpose you have two types of pumps are there. One is jerk type pump, second one is distributor type pump. Okay, you have two types of pumps. First we'll be discussing about jerk type fuel pump. Fuel pump. Okay, look at this diagram. This is a jerk type fuel injection pump, like injection system or injection pump. Okay, so here it consists of what? Plunger. It consists of reciprocating plunger, which is located inside the barrel. Okay, you can see this is the plunger. Okay, this green color is there, no? Green color, that is the plunger. Which is reciprocating inside the barrel. Okay, inside the barrel, that is reciprocating means what? It is moving up and down. Okay, this plunger will reciprocate. Yes, yeah, this will reciprocate in this way, up and down. Okay, and this plunger is driven by camshaft. This plunger is driven by camshaft. Okay, on the camshaft you can see cam lobes. This is nothing but cam lobe. Okay, this is nothing but cam lobe, and which is a part of camshaft. Okay, now we'll see the working principle of jerk pump. This is the diagram. Now generally a fuel is always available under the relative low pressure. Okay, see in this diagram, axial movement of the plunger is through camshaft. It is axial movement of the plunger, it is controlled by the camshaft, and its rotation, the plunger have two motions. One is vertical motion, it is controlled by the camshaft cam, and also the rotary motion. You can see that rotary motion, it can rotate. The plunger rotate 360 degrees. It can rotate 360 degrees. Okay, so then that rotary motion is controlled by a rack, which is not visible in this diagram. That is controlled by rack. You can see the rack in this picture. You can see this rack. Yes, this is the rack. Yes, this is the rack. What is a rack and pinion? Rack and pinion mechanism. Okay, so when this rack is traveling towards front and back, obviously the teeth that is present on the rack is meshing with this gear. Obviously the gear will rotate. You know that principle. Okay, this because the teeth is meshing with the gear. When the rack is traversing to and fro, because of that movement, since the teeth is meshing with the gear will rotate. If the gear is rotating, you will get rotary motion. Okay, the same thing, you will get the rotary motion for the plunger by by the rack and pinion mechanism. Okay, Yes. Now we'll see how that fuel is metering in pump, jerk type pump. Okay. First here, initially this plunger is located at this position, at the low position, because the cam is there, no, the cam lobe at the minimum position initially. Okay, at the minimum position initially, when the cam lobe is at the minimum position, clearly look at the figure. When the cam lobe is at the minimum position, obviously this is the least position that plunger can move downward. Okay, this is the least position that plunger can move downward. Okay, when the plunger at this low position at the bottom level, at the bottom, that means we can say in the engine the piston is moving up and down. The top position is, we are calling it as top dead center, and the bottom position we are calling it as BDC, bottom dead center. Similar way here also, this we can consider as a bottom dead. So when this camshaft is at the minimum position, when the camshaft is at minimum position, what is happening? The fuel that is present in the fuel tank is entering through this passage inlet port. You can see this is the inlet port. Okay, so this is the inlet port, because that inlet port is open and the fuel will be entered here. The fuel will be entered here. Okay, so now here and that is inlet. The inlet port is also called as supply port. Okay, so that fuel, whatever the fuel that is entered here, okay, that is pressurized. Pressurized. How it is pressurized? Because how it is pressurized? The cam lobe is rotating at a maximum position. Okay, the cam lobe is rotating at a maximum position, so that's why this plunger will be lifting at a maximum position. Okay, maximum position, and it pushes the fuel and pressurizes the fuel. Okay, this lifting, this cam lobe, since the cam lobe is lifting upward direction, it is coming into the maximum position. Obviously this plunger will move upward direction, and the fuel present here will be pressurized at a higher pressure. Okay, now you can see above this orange color, you can see one valve is there, that is nothing but check valve. Okay, that is nothing but check valve. Above the check valve you can see spring force is there, no, that spring force is available above spring loaded check valve. Above that spring force is available. Okay, and due to the spring force, what is this spring force is, this is not allowing the fluid, or what is that charge, diesel charge, diesel, since it is in diesel engine, I'm talking about diesel fuel, it is not able to send into the injector nozzle. Okay, it is not like this is outlet is closed due to the spring loaded force, okay. But if the pressure inside the barrel is increased more than the spring force, if the pressure inside the barrel, here, if this pressure inside the barrel is increased further more than the spring force, obviously the spring loaded valve will be opened. Okay, spring loaded valve will be opened, and the charge, the diesel fuel will be entered through the outlet port, and that is entered into the injector nozzle. Through the injector nozzle, it goes to the cylinder. Okay, so meanwhile you can observe that there is a one more passage here, that is nothing but, spill port. It is not mentioned here. There is one more port here, that is nothing but spill port. Okay, spill port is available. Okay, so what is happening, initially I told you, when this what is that when the plunger, it is a minimum position, the inlet port is opened, and the charge is entered, and the diesel fuel is entered. Now when it is traveling upward, both the inlet port and also spill port is closed. Okay, I'll tell you the purpose of spill port. Okay, both the inlet port and spill port are closed, and the charge alone is compressed. The charge alone, that means the diesel fuel alone, it is compressed, and the compression pressure, if the compression pressure, due to the compression pressure, obviously if it is extended beyond the spring force, obviously that check valve will open and the fuel will enter into the nozzle. Okay, then once this plunger reaches the top position, top position, obviously this valve will open. Okay, that is fine. That is fine. But what about after entering that fuel into the nozzle? Okay, after entering the fuel into the nozzle, now the fuel charge should be cut off here. Okay, that means this valve should be closed. That outlet valve, outlet port, that is outlet port should be closed. How to close that outlet port? For that, now the spring port, the spill port will help you. Okay, so how the outlet port is closed now, you check here. Now when it is reaches to the maximum top dead center, obviously it cannot travel further. Okay, when it reaches, this plunger reaches the top dead center, it cannot travel further. Okay, now after sending the fuel, the spring port should come downward position, like it has to the valve, the check valve should come back to the original position, so to do that, what is happening? Now this spill port is opened by using the rack. You know, the backside I already showed you there is a rack and pinion mechanism. You can rotate that plunger. On the plunger, you can see that helical groove is present. You can see this picture, these pictures. Okay, there is a helical groove that is present. Okay, Okay, now when you are rotating this plunger, the helical groove, if it is matching with the spill port, okay, so there is a liquid, there is a fuel, diesel fuel, which is already filled in the helical groove, is spilling out. It is spilling out, so that the pressure is decreased. If the pressure is decreased here, obviously it will come back to the original position. Whatever that check valve is lifted up, now it will come back to the original position due to the reduced pressure. It come back to the original position. Okay, understood. So in that way, this is operating, that fuel is sending, and again the same process. Okay, it is repeating in a cycle way. And now here, the fuel, whatever the fuel it is sending into the injector nozzle. Okay, all the times the fuel is not metered equal quantity. Okay, it depends on the need. Means what? If you are operating that at higher speed, you need to send a more amount of fuel. If you are operating at a less speed, you need to send a lower amount of fuel. You know that. Okay, you need to meter it according to your requirement. So what is happening, and this spill port will help you in order to meter the sufficient amount of fuel that is entered into the nozzle. Okay, how it will meter, you see here. Now the fuel, excess fuel, whatever that, when you are rotating that, changing the position of the helical surface, you know, changing the, actually the amount of fuel supply depends on the load of the engine. Okay, the amount of fuel supply depends on the load of the engine. Now when you are changing the position of the helical surface of the plunger, this will changing the position of the helical surface of the plunger will change the quantity of fuel that is metered. Okay, so this changing is happening by what? By rack and pinion mechanism. If the rack and pinion, according to the rack and pinion mechanism, if the rack is travels to and fro, obviously the helical groove is there. No, slowly the helical groove, it will open wide or wide. If you want to meter more quantity of fuel, it will open wide. Other less quantity, it will open less. Okay, based on that, it will move to and fro position. Okay, now that is done by what? That is done by rotating the barrel by rack and pinion arrangement, and also the reciprocating motion of the plunger is done by cam motion, lifting of cam motion, reciprocating motion, that is done by lifting of cam motion. Okay, so this is the jerk type of fuel injection system or injection pump, jerk pump fuel injection system. It is very simple. Okay, and you need to draw the same diagram. You can draw related to that diagram. Okay, next, okay, the same thing what we have discussed. Here it is shown fuel is in the inlet port, all those things. So we talked about this is see, this is the inlet port. We can call it as port A. Okay, so this is what? Outlet port. B, and this we can talk it as spill port C. Okay, this is spill port C, and this is inlet port A, and this is outlet port B. So accordingly, you can write the theory. Okay. So yes. Now the second classification. Now the second classification is nothing but distributor type pump. Distributor. The second one is distributor type pump. Distributor type pump is very simple. Look at the diagram. Yes. No, this diagram distributed type pump. Okay. Yes. Now this distributed type pump has only one single pumping element. Does not have multiple pumping elements. Only it has only single pumping element. Okay. And the fuel is distributed to each cylinder by means of rotor. You can see these are all the rotors. Okay, this is rotor. Yes, inside it is rotating. This is the rotor. Yeah, this is rotor. Okay, okay. The fuel is distributed to each cylinder by means of rotor. By means of rotor. Okay. So rotor, what is the function of rotor? It will rotate. The rotor will rotate. That will see that how the fuel is distributing in the distributed fuel pump. Okay. Now there is a central longitudinal passage in the rotor. You can able to see there is a central longitudinal passage. Now what is that central? This is, you can see this is the central longitudinal passage. Okay, this is the central longitudinal passage. Yeah, this is the central longitudinal passage in the rotor. Okay, there is a central longitudinal passage in the rotor, and also two set of radial holes. Two set of radial holes. So this here one set of here one set of radial hole. This side, left side and right side, and another set of radials left side and right side. Okay, both are at different positions. Remember, both are at different heights. Both are the one set of radial holes at this position, at this height, and other set of radial holes or at a somewhat a different height. Okay, but both are in line. You can see that in the picture. See here, you can see these are all the radial holes. These are radial hole at this position A, and this is other set of radial holes that is at a different height. Okay, each set is equal to the number of engine cylinders. Okay, located at a different heights. That's why I'll tell you. One set is connected to the pump inlet via central passage. Okay, one set is, you can see this is one set. Okay, this is one set. This is connected to pump inlet. This is the inlet. This is the inlet. Okay, one set is connected to the pump inlet via central passage. Okay, now the second set. This is the second set, right? This is the second set at a different height. The second set is connected to the outlet. Second set is connected to the outlet delivery line. Okay, leading delivery line, which is leading to the injectors of various cylinders, which is sending to the injectors of various cylinders. The outlet, from the outlet you are sending it to the various cylinders. Okay, now you see here the fuel is drawn into the central rotor. First the fuel is drawn into a central rotor passage from the inlet port. Initially the fuel will be entered through the inlet port. When the plunger moves away from each other, where is the plungers? These are all the, this is the plunger. Okay, you can see here, this is the plunger. Can you able to see in the CAD model? You can see these two are the plungers. Okay, So when this set of plungers, when the plungers are moving away, so when these plunger are coming at this position, these are all compressed, that is moving towards. When these plungers are at this corner positions, it is away. Okay, when these plungers are away, from the center, from the central path, you can see here the direction of the plunger. Okay, yes, away from the central passage. Okay, when the plungers are away from the central passage, what is happening? The fuel is drawn into the central rotor passage from the inlet port. Okay, from this inlet port, the fuel it is entered into the central passage when these plungers are acting away from the central passage. Okay, whereas next, whenever there is a radial delivery passage in the rotor coincides with the delivery port for any cylinder, the fuel is delivered to each cylinder in turn. Okay, so when it is rotating like this, when the what is the rotor, when it is rotating like this, what is happening? When it is rotating, what is happening? This valve, what is that? This passage which is closed now, due to the rotation of the rotor, this is going and coinciding with the outlet port. Okay, so you can see that in the second figure. Now when the plungers come towards, when the plunger comes towards each other, obviously now the fuel that is passing in the central passage, now this is coinciding with the outlet port, and the fuel is sending from the outlet port to the cylinders. Okay, each cylinder. So here you can see how many cylinders. For example, one cylinder means how many? Inlet valve 1, outlet valve 1, like that. Okay, so 2 cylinder means inlet valve 2, outlet valve 2, like that. Okay, 3 cylinder, it depends on the number of cylinders. If number of cylinders are there, it depends on the number of cylinders. Okay, now in this diagram you can see how many inlet valves are there, how many outlet valves are there, how many inlet valves. Now suppose you cut this, you cut this diagram, that means you cut this distributed pump here horizontally, cut it like this way, remove this portion and look at from the top view. How many are there? One, 2, 3, 4, 5, 6 inlets are there. Okay, so but the looking the diagram, you cannot see. If you cut that, then from the top you can able to see that how many passages are there. Okay, so 6 cylinder. If 4 are there, 4 cylinder engine. If 2 are there, 2 cylinder engine. Okay, it depends on the number of cylinders. The number of inlet and outlets are depending on the number of cylinders. Now here like outlet port. Now cut this in this way, look at from the top how many passes are there. 1, 2, 3, 4, 5, 6 in. Okay, 6 cylinder, 4 cylinder is there, 2 cylinder is there, 1 cylinder is there, 6 cylinder is there. Depends on the number of cylinders, the arrangement will be changed. If for example 4 cylinder is there, you need to meter the fuel to the 4 cylinders. Okay, meter the fuel to the 4 cylinders. So 360 divided by 4, how much? 360 divided by 4, how much? ఎంత వచ్చింది? 360 divided by 4, 90. 90 degrees. That means 90 degrees rotation of the 90 degrees rotation of the rotor. You will get the coincidence of inlet port with the central passage, so that you can meter the fuel. Okay, you can enter the fuel. Okay, so accordingly, number of cylinders, if it is 6 cylinder engine, 360 by 6. Okay, so 60 degrees. For every 60 degrees rotation of the rotor, obviously it will coincide with the inlet and also the outlet. You will get the fuel that is entered here, and it is sending again to the outlet port, which will be sending into the cylinder. From the outlet, it will be metered to the cylinder according to that. Okay, and so the main advantage of this type of pump, it is lies in the small size, and this is small size in compact and is lightweight. Okay, this about the distributed type fuel pump. It is very easy. You can see this components, nothing but only stator, which is fixed, the rotor, next inlet port, okay, outlet port, plunger, this is the plunger. Yeah, these are all the plungers. Plunger springs are there, okay, compression, expansion, and like in order to move away and towards, you need to have plunger. Okay, these are all the different components.